Hello Algebra 2 class, how are you? It is Kevin with our first video lesson from our new chapter. Luckily, we finished a chapter before the DC trip and before all this happened, so we're going to be starting a brand new chapter on a fresh slate. It's chapter 6 in your textbook, which is about radical functions. And we're going to be starting radical function by just talking about functions in general. And today we're going to talk about operations on functions. Specifically, we're doing compositions of functions for this first lesson. The second part of this lesson will deal with sum, difference, product, and quotients. I'm breaking it into two parts so that the videos are not too long. So this should be about 10 minutes or so, I would guess, but it could be longer. I'm not sure. This is my first time doing it. So let's see what happens. Let's start with an example. Now let's just say you had one of these cool things that you could buy. Now this, ladies and gentlemen, is a Tron light cycle. Now this picture right here happens to be a real light cycle that somebody built and sold for $77,000. But do not worry, we are not going to spend $77,000 on this. Let's assume I owned a motor vehicle dealership and I was going to sell you this bike for $22,500. But because I'm a nice guy and because I like you, I'm giving all my customers a 12% discount. However, the company itself is going to offer a rebate of $2,000. So that's a double incentive right there. So you're going to get them both. The question is, which one first? Which one will give you the most discount? This is an example of a composite function. We have two functions, the 12% discount and the rebate of $2,000. And those two functions are going to be combined to give you one final answer. So let's look at the mathematics of it and see what it looks like. So first we're going to offer you a 12% discount, and then we'll do the rebate of $2,000. We'll do it in that order and see what it turns out to be. So what we are going to do is we are going to start with the price of $22,500, and I'm going to take off 12%. Now if you remember, taking off 12%, what do you take it off of? You take it off of the original price. So remember, taking off 12% is the same as leaving on 88%, because 100 minus 12 is 88. So if you're not sure about that, you can trust me on that or check out your percentages and decimals. Anyway, so if I multiply 22,500 by 0.88, I get the answer of 19,800. So that's how much the discount is. But wait, we're not done. Now we're going to take away the rebate. So we're going to take that 800 and subtract 2,000. That's going to leave us with a total final price of $17,800. Okay, not bad. Okay, but now let's do it the other direction. Let's start with the rebate, and then we'll take the discount, and we'll see what that gives us. So, if we do the rebate first, so we take the original price of $22,500. Now I'm going to subtract the $2,000 rebate. Gives me $20,500. And then what am I going to do with that? I'm going to take that price. I'm going to take off the 12%, or leave on the 88%. So I'm going to multiply that, and the answer I would get with that would be, and hang on, let me check, $18,040. That's how much that would cost. So as you can see, the price of $18,040 is a little bit higher than our price of $17,800. So I'm guessing probably want to save some money. I'd go with the 17,000. I would go with the discount first and then the rebate. Let me show you what that looks like with an equation. Okay. So we're going to take our equation, and here's what we're going to do. We're going to have our first equation. We'll call it F. And we'll say that F was the 12% discount, or we're leaving on 88%. Then we're going to take the other function, which is going to be taking the price and subtracting $2,000. These are two functions. We did one, then we put the answer of that one into the other one. So it's how do you see it all together? So I'm going to introduce you to something that you haven't seen before, and it's going to be a little weird, but it's going to call it a composite function. We're doing one function inside of the other. Now remember what f is. F is 0.88x. But what is that x? X is whatever I decide to put in. I put in 4, then it's 0.88 times 4. I put in 17, it's 0.88 times 17. I put it in smiley face, it's 0.88 times smiley face. Now, I'm putting in this whole function g of x. Well, what is g of x? G of x is this whole thing. So I'm going to take 0.88, and I'm not going to multiply it by x. I'm going to multiply it instead by x minus 2,000. This is your whole composite function. Now, what does it really mean? If I take any value of x, like in this case 17,000 or 22,500, I'm going to take that, subtract 2,000, take that answer, and multiply it by 0.88. That's a composite function. Don't worry, if it's a little weird, it'll get clearer, I'm hoping, when I do other parts of this video. So let's do it the other way. What if I did the function of g, and now I did f first, and I'm going to put the answer of f into g. Now g is x minus 2,000. Okay, but it's not x. I'm not putting in x. I'm putting in f of x, which is this whole thing. So instead of x, what I'm going to have is 0.88x minus 2,000. Okay, a little bit strange, but let's see some real examples. And once you see some real numerical examples, it might become a little bit more clear. Take g of 1. Now g of 1, remember g is this. G means x plus 4, something plus 4. Well, that something happens to be 1, and of course 1 plus 4 equals 5. So now I know that this equals 5. Well, now I'm going to take that 5 and put it in for f. So my result from this one is going to be my input to the next one. And f is 3 times x, or 3 times something. Well, that something happens to be 5, and 3 times 5 is 15. So f of g of 1 equals 15. That's how composite functions work. Okay? We've got 5 more examples to do. If you have any trouble with these, maybe you can pause the video, watch it again, or I would say watch it through first and decide what you need to do, and ask me if you have any questions. All right, we're finding h of 0. Well, h is this, x squared minus 1. So it's going to be 0 squared minus 1. 0 squared is still 0, and 0 minus 1 is negative 1. So my answer now is negative 1. So I'm going to put that answer into the function of g. And we did g just before. G is x plus 4. So it's not x plus 4, but it's negative 1 plus 4, which equals 3. So g of h of 0, when it's all said and done, equals 3. Okay? F of negative 1 instead of 3 times x, it's 3 times negative 1, which is negative 3. All right. We're going to put that negative 3 into g, because that's what's out here. So g of negative 3 Negative 3 plus 4, which equals 1. So g of f of negative 1 equals 1. Now, if you have any questions about soft brackets versus hard brackets, it doesn't really make any difference in this case. It's just how you separate them, and you can do anything that you want, really. All right, f of 5. It's 3 times a number. Well, 3 times 5 is 15. And then put that 15 into the function of h. H is x squared plus 1. Well, that x happens to be 15. Do you guys remember what 15 squared minus 1 is without a calculator? Well, it's 225. And I did not calculate that. I happen to know that one. I know many of my squares. Well, not all of them. I know them up to 20. So, okay. Now, what's this thing? You've never seen this notation before. But remember, that's a circle. That's not a dot. It doesn't mean multiply. It's a composite function. It means of. This says f of h of g, which means we're going to take g, put its answer into h, put its answer into f. We're going to start with the inside parentheses. We're starting with g. G is x plus 4. We're putting 1 into g. G of 1 is 1 plus 4, which is 5. So our answer is 5. Well, with that 5, we're going to put it in for h. Whoa! Excuse me, guys. Let me fix that. There we go. Put it in for h. Well, we know that h is x squared plus 1. H of 5, which equals 5 squared plus 1. And then 5 squared is 25. And you know me. Here I go again. It's not plus 1. It's minus 1. All right. 5 squared minus 1. 25 minus 1 is 24. So now I've got 24. And in place of that 24, now I'm going to put it into f. And f is 3 times x. So f of 24 equals 3 times 24, which is 72. That's how it works. So this answer right here is 72. All right, one more. And then this will be the end of this first video, and then I have a second video for the rest of the worksheet. So negative 2 is what we're putting in, and we're putting it in this order. H is first. So h of negative 2, which equals negative 2 squared minus 1. Remember, negative 2 times negative 2 is 4. 4 minus 1 is 3. Taking that 3 and putting it in for g. And g means x plus 4. It's not x anymore. Now we're going to put in 3. 3 plus 4 is 7. 7. And now we're going to take that 7 and put it in for f. F is 3 times some number. So f of 7 is 21. So this whole answer here is 21. Okay? Close to my birthday. If you read it backwards, 712 is there. So, anyway, there you go. That's our first part of composite functions. Hopefully that made sense. If not, rewatch the video, give me an email, comment in Edmodo, or even look up composite functions online and see if somebody else can make it more clear for you. So, glad you were listening, and I will see you with the next video for the second half of this worksheet.